Okay, I will begin with the presentation now. Okay, Assalamualaikum to Dr. Zulkifli. We are from FRS Technology and today we will be presenting our products entitled Smart Soy Sauce Mixer Machine. Okay, before I begin, I will first introduce each member in our teams. My name is Rana Ainun and I am a project director for this team.
And my name is Noor Farhana. I am the System Director for
And
this team.
My name is Rizwan Hakimi. I am system designer for this project.
okay, now we will proceed to the introduction of this project. Okay, soy sauce is a salty liquid condiments that fermenting soybeans and wheat have historically made. Therefore, the production method might vary greatly, resulting in considerable difference in flavors and texture and health hazard. Nowadays, chemicals production is a lot faster and less expensive techniques of producing soy sauce, as it can manufacture this rather than months. Furthermore, the final products lack many flavors, chemicals that are created during traditional fermentation make it is less appealing in terms of taste and flavor. As a result, additional colors, flavor, and salt are added. Okay, for the next slide, there are two problems regarding this soy sauce manufacturing system. The first one is that there is much waste that possibly happens during soy sauce production. The second one is the process of before and during the production and fermentation of the soy sauce is not hygienic and clean. Okay, for the next slide is objective. Okay, in order to achieve our target and goals for this product is that we have come up with three objectives, which are the first one is to improve technology and performance of the soy sauce making machine. The second objective is to reduce the workforce by increasing the productivity and capacity of the production. And lastly is to enhance the features and quality of the soy sauce for better production.
Okay, I will explain start from the block diagram. This is the block diagram for our device that we plan to do. And the starting of the sensor, there are 4 sensors that we plan to implement at the device. And the first one is the temperature and the humidity sensor. The second one is the turbidity sensor. That is for the quality monitoring for the soy sauce liquid in the process. And then the third one is the pressure sensor. This is the sensor we plan to put at the hydraulic press. And this is to monitor the process of the pressure. The hydraulic press that will uh, press the liquid from the soybean. And the last one is the flow and level sensor. And all the sensor will go into the microcontroller, and then the microcontroller that we discussed and agreed to use is the Node MCU. And then the power supply will supply the power to the microcontroller, and the connection will go to the IoT cloud for the user. And then all of the sensor will go to the device, to the output, and there is the mixer motor, the in the fermentation tank, and then the hydraulic press, and also the solenoid valve. Okay, next. Okay, this is the context diagram for the process. And start from the beginning is the microcontroller, biosensor, the temperature and humidity sensor, the pressure sensor, and the flow and level sensor. So it will go to the process, and the process will divide into the four their tasks. That is the temperature and humidity sensor is to sense the right level of the temperature and humidity in the fermentation tank. And then it will go, the second one is to the pressure sensor. The pressure sensor will sense the hydraulic press monitor when the pressure is pressed on the soil. And then the next one is the biosensor. The biosensor is to measure the quality content in the soy sauce to observe the quality in the soy sauce liquid. And then the last one is the flow and level sensor. The flow and level sensor is in the beginning of the process, and the solenoid valve will start and stop the liquid that put the ingredient into the tank, and then all of this will go to the worker for the observant. Okay, next. Okay, this is the flowchart of our device, and start from the beginning to the microcontroller, and then it will go to the read sensor. All of the sensor, this sensor is, as I said, mentioned earlier, it is 4 sensor, and then the flow and level sensor is from the mixer motor, and then the flow and level sensor will go to solenoid valve to stop the flow entering the mixer motor, and then after the flow and level sensor is on the right level, it will start the mixer motor. And then the biosensor and the temperature and humidity sensor is to observe in the fermentation tank to get the right humidity and the temperature, and also the quality of the soybean in the fermentation tank. And then the pressure sensor is for the hydraulic press on the soybean, and then it will send data. uh, if no data to send, it will go all over again to read sensor, and then if yes, it will display the real time on the Blink app and save data to the cloud, and it will end the process. Okay, next. Okay, this is the application of our system. The first one is it can be used to add the small startup soy sauce company, and then the second one is the process of the soy sauce production is more hygienic, and then to maintain quality of the production, thus reduce waste. And then the last one is can be automated, thus it will reduce manpower. Okay, next I will pass to my friend.
Okay, so now I will explain to you about the operational analysis. So for the first one is the operational entity breakdown, the OEB, where the operational actor are the workers and the technician, and the operational entities are the smart soy sauce mixer machine using microcontroller, mix ingredients and the store data to cloud. And it contain from the smart soy sauce mixer contain from the mixing ingredient and the store data cloud. So now for the operational capabilities, the OCB. So here there are two operational capabilities, which are the mixing ingredients and the maintenance. The involvement of the mixing ingredients are between the co-worker and the smart soy sauce mixer machine using the microcontroller, while the operational capabilities are involved between the technician and the smart soy sauce mixer machine using the microcontroller. We'll proceed to the operational entity scenario, OES. So as I mentioned before, the operational capability, there are two, which are the mixing ingredient and the maintenance. So right now I will focus first on the mixing ingredients, so which are between the workers and the smart soy sauce mixer machine. So for the first one, the workers will turn on the system in order to switch on the machine. Then the machine will be initialized. This is where all the sensor will be calibrated, and it will check the amount of the ingredient before the mixing of the ingredient. So then after the machine already have initialized, it will start to mixing all the ingredients in order to make the soy sauce. Then it will send the information to the worker in order to monitor the flow of the mixing ingredient. And at the same time, it also the workers can also check the history data retrieved from the cloud, where the data is saved in the cloud from the machine. So right now is the OES for the maintenance between the technician and the smart soy sauce mixer machine. So the technician can set up the system in order to test run the setup before the machine can run to mix all the ingredients. And the technician can also have to maintain the system if the system encounter a system breakdown or before the machine go into the breakdown, in order to make the machine run smoothly throughout the process. So this is the operational analysis of the operational architecture diagram, OAB. You can see here there's workers, smart soy sauce mixer machine, and also the technician. This is the activities extract from the previous operational entity scenario. So you can see here, before the initialize the machine, there will be a rate sensor as mentioned before at the context diagram. The rate sensor each amount of the ingredient. And also the history can also be retrieved from the data cloud. And you can also see here the involvement between the technician and the machine in order to set up and maintain the system before the machine can be run and before the machine be breakdown. Okay. And then last but not least, the operational activity interaction diagram, the OAB, throughout the process. As you can see that the OAB is to model and display the operational interactions. As we have already defined the interaction through the scenarios, and it display the existing interaction. And this is the activity boxes after the relocating in the working area. It also allow us to define operational process of the operational activities and the interaction. So you can see that where the process is linked between the activities. So for example here, the system maintenance and the system breakdown for the maintenance process. So here is the storing data process where the data is saved in the cloud, and also it can check the history data. So for the next one is the setup process where the system is set up in order to run the setup. Then the mixing process, it will be mixing all the ingredient and to monitor the flow of the mixing ingredient. And then lastly is the starting up process, turn on the system and also to initialize the machine. Where also the machine is picked by the sensor to read the each amount of the ingredient.
Okay, now I will explain two types of architecture for this product. The first one is a physical architecture. Physical architecture is consisting of views of the physical solution, and therefore, by referring to our block diagram, we have come up with the analysis for the physical architecture. You can see for the physical architecture, the flow is that it will start with microcontroller and then proceed to the flow and level sensor and to the solenoid valve, next to the mixer motor, and for the fermentation tank, and to measure the value of the fermentation tank, for the fermentation tank, we need a biosensor. As before we leave the process, we need to hydraulic press and pressure sensor before it can reach user interface. Okay, next, as we have known, a functional architecture is a set of functions and their sub-functions that defines the transformations of input flows into output flows that performed by the system to achieve its mission. Therefore, by referring to our flowchart, we have come up with this analysis. You can see that the physical sensor will have a contact with the microcontroller before it can process to the local processing unit, and then to the wireless communication module, internet, and next to the server and data storage. Okay, not only that, microcontroller also will send a data data to the relay for it to control the fan, heater, and next voltage regulator. After the system has been done, monitor through the phone application and for the remote monitoring. As for the heater, it will need voltage regulator for the next process, and lastly, soy sauce packaging for the end result. That's all for me.
Okay, for the allocated architecture, this allocated architecture is basically physical architecture combined into the functional architecture to make it more understand. So from the physical sensor, all of the sensor is come up into here. All the sensor is explained by my friend just yet, and then it will go to the microcontroller, and then the microcontroller will also go to the local processing unit, and then for the down part is the relay part. The relay part is using for the mixer motor and the hydraulic press, and that will go to the fan and heater. This is for the fermentation tank to maintain the humidity in the fermentation tank, and then it will go to the voltage regulator, and this voltage regulator also used at the hydraulic press, mixer motor, and also solenoid valve. And lastly, it will go to the soy sauce packaging. Okay, we come up to the microcontroller on the second side. It is the local processing unit, and then it will go to wireless communication module, internet, and server. This until and end up until the phone application and remote monitoring. All this using in the user interface. Okay, I will pass to my friend.
And then lastly, for the conclusion, this equipment is equipped with the technology towards the Industry 4.0, as we use the microcontroller, no MCU, in order to make the machine monitor by using the Blink application. Next, it can make the more efficient manufacturing techniques, as we want to eliminate the waste product. And then lastly, to increase production and the quality of the product. And that's all from us. Thank you.
Okay, thank you for your presentation. Okay, maybe I can understand in the process of buat kicap ni, dia banyak, they use a lot of tank kan. In
Yes, correct.
setiap tangki tu is where you mula-mula proses dia selepas mula-mula prepare the material kan, prepare the soy punya ni, soybean tu, dia cuci dan bubuh dalam tangki tu kan, and then they go through process of fermentation kan. Okay, sebelum pada fermentation dia kena tambah raruan macam-macam, garam dengan yeast ke what, I don't know lah. Tapi the fermentation tu berlaku agak lama kan. Berapa lama dia buat simpan dalam tangki tu?
For my research, I think a few weeks. Because of the chemical nowadays.
Okay. So your system ni, so setiap tangki tu ada satu sistem.
Yes.
So okay. So tapi macam ni, because the filling up tu macam if I can understand, I just want to visualize you have the tangki ni macam nak masukkan ingredient tu is kalau manually somebody will guna cebok bubuh the soybean, bubuh air, bubuh garam. So I can assume that in your system ni the filling up tu is done through pipes, through guna pipe, and dia masuk automatically kan macam tu. Macam katakan air tu dia dah masuk daripada pipe dia, ataupun macam mana? Is it manual?
No sir, sebab yang as I explained just yet, you use solenoid valve to start and stop the filling into the ingredient tank. Okay.
So tapi macam the raw material tu macam the soybean tu some still need operator to feed into some kind of hopper ke macam mana?
Kalau untuk soybean ada level sensor, tapi kalau for the beginning because it's from other place, right, so it must
still manual lah kan.
Manually, right.
Tapi bila dah habis proses of fermentation dia monitor lah. Okay, you monitor dia punya whatever temperature, whatever chemical punya ni kan. Bila and the process tu dia macam mana? Dia just because of time up ke dia ada bila after certain time tu dia ada sensor monitor, okay, what is the nitrate punya level lah, whatever, dan macam mana to, how does it end the process?
Before the end of the process, because the hampir near to end the process is the pressure hydraulic to press out the liquid. So at that time, the quality content of the soy sauce is already monitored. So after the press is considered like okay.
So okay, macam daripada tangki tu dan the whole thing is extracted and masuk into a press. I mean bukan tangki itself dah ada press.
Belum.
No, so dia pump out masuk into the press lah kan?
Yes.
Okay, macam one thing, the process, the whole process is time dependent kan? Mana masih berapa minggu. Saya rasa yang kicap, yang Jepun tu setahun ke apa, I don't know. Lama fermentation process. So macam your system ni satu, you ada missing. You need some kind of real time clock lah.
Oh, okay.
Okay, yang nampak because the process. Ya, prosesnya ada macam-macam. Dia guna apa? ESP32. ESP32 tak ada real time clock. Tapi kalau okay, tapi ini detail lah. Mungkin suggest macam proses dia lama, berminggu-minggu lah. Sometimes tu there ada possibility the system to stop operation tu. Ada fault, dia berhenti. Tapi bila restart dia boleh tak continue ataupun dia start reset balik. So maybe that is something that you have to consider lah. Okay. Tapi your presentation is good. The way you present the problem is very clear. Okay, and I mean simple but clear, and the use of capella pun okay lah. I mean I appreciate that. I mean you show your ability to use capella and okay, and in fact something that dah boleh go to industry, go to the food industry, kilang kicap, you have a system. Tapi one thing you have to do is that you have to draw for example, the physical system, the tangki macam mana, the sensor. That one is missing because kalau you nak present to kilang kan, dia tak faham sangat this electronic punya thing, tapi dia nampak, dia kata ni equipment dia, machine dia macam ni, tangki dia macam ni, and then you tunjuk this where you attach the sensor, this how you fill up the tank and so on kan. So okay, I think it's quite applicable. It's realistic and applicable. That is my perception lah. Yeah, because unless betul-betul kalau betul-betul boleh present to the kilang kicap itself, then that is a true test lah. Sama ada. Tapi what you have here, kalau dah present, kalau kat kilang buat kicap ni, dia kata ni tak betul ni, tapi you know where to modify it, how to improve it. Because dia ada something based. So, okay, ada apa-apa soalan ni? Okay, on the logbook, I want everybody to submit. Okay, there will be a logbook to try to be as individual lah. Tapi of course, there are certain part of the logbook tu will be common. Because logbook ni saya tak nak you bagi from week 1, week 2 macam tu, tak ada. Tapi bila you actually start buat capella, buat planning untuk buat the project ni kan, buat designing the project ni, and then something significant to report. Benda yang ni lah, kalau cakap hari ni saya buka page ni, hari the next day you buka page ni, I'm not interested. Tapi katakan, okay, you nak belajar capella, you hadapi some problem. So, okay, what is the problem? How you overcome that? Something significant. And then, so ada set up VIE. So every day I need to upload. Macam presentation dengan report tu will be the same lah. I mean common kan. Okay. Tapi I still everybody to upload because senang saya nak check siapa dah hantar, siapa belum. Kalau tidak, tengok Ridwan dah check, dan kena check pula go down Surana, dan kena check Fahana, dan list ada 47 dalam tu kadang-kadang dah check nak ni. So yang ni sekali tengok dah tahu the numbers. Okay. So
So when is going to be the due date for us to submit the logbook and the report?
Monday.
Monday, okay.
Nanti dia jangan ambil masa sangat because you ada lagi siapa yang kena buat FYP lagi, siapa yang ada exam lagi kan, so don't waste your time. So you already
So the report is going to be group and the logbook is individual.
Individual, tapi logbook I can understand lah, but certain portion tu be common portion lah. Tapi yang sini kalau boleh, if I can see what are the different things that each member of the group buat, hopefully I can see that. So tak nak everybody kalau tidak, kenapa semua sama, tiga-tiga buat sama, tak bagi different job ke, tak bagi kan. So because I would expect kan dalam team tu you divide your task kan. So you bila cerita tu yang your individual effort tu kena highlight lah dalam logbook. Okay, apa ni your report tu, some of the group yang present tu ada bagi suggestion boleh improve kan. Tapi macam in your case tak ada apa lah. I mean what you present is already quite clear. Tapi kalau maybe you nak tambah, kalau it's up to you lah dalam di final report. Okay, macam proses nak tahu macam buat kicap dia punya fermentation tu kan, dia nak monitor. So setahu saya, ingat yang present manufacturer ni tak ada, dia prepare everything, dia perap dia berapa minggu ambil, dia tak ada monitoring pun kan. I don't think they have monitoring. Tapi in this case, you boleh highlight that your system monitor masuk internet, and then the owner tu tak payah pergi buka nak check. Nanti sekarang ni kalau nak check dah masak tak masak, dia buka. Dan macam buat budu kan lah. Budu lah Malaysia tu. So because of that, dia nak check sama ada pressure, dah masak lah kan, by measuring pressure kan. Tapi kadang-kadang tu buat-buat, kenapa tak ada changes ni, pressure tak naik, proses fermentation tu tak berlaku. So dia tak payah tunggu sampai ni, maybe ni dah awal-awal lagi dah boleh, mungkin preparation material tu tak elok kena buang, okay? Tapi tak payah tunggu sampai habis term proses berapa bulan kan. So this you can see guna through IoT, guna dashboard and so on lah. So the advantage of using IoT tu, and maybe you can highlight that in your report, because dia dah boleh monitor, the data is uploaded into the cloud. For example, one thing, process monitor dia punya pressure. Pressure to determine how fast is the fermentation process kan, because of the fermentation will produce carbon dioxide kan, increase pressure. Tapi kalau bubur tak ada increase pressure, that mean dia punya fermentation is not happening. So daripada tunggu dah 3 minggu apa 6 minggu apa ada buka, nothing happen. Yang ni dia dah tahu dah weekly dia punya dah ada dah proses dia punya ni boleh improve the quality and so on lah. So boleh cerita sikit about advantage using the IoT lah. Kalau you boleh describe that in your tambah sikit report kalau you nak lah. Okay. Tapi I'm quite happy lah, quite satisfied with your presentation. Okay, ada apa soalan, ada komen?
So sir, the format for the report where you upload in the file teams, right?
Okay, the template tu lah. Tapi yang towards the end macam tu, that is okay, macam top level diagram tu, that one you kena describe. And then the detail system tu, okay, that's where you need to have your diagram of your physical device, the equipment and everything lah. Not just a block diagram electronic lah, but how they be interface, okay. And then describe software there. Software tu boleh masuk flowchart lah, okay. And then macam test planning kan, test plan, okay. Boleh masuk, okay, boleh describe what the process. You can extract from the material bagilah, just for ni. Tapi kalau macam tadi you ada masukkan macam ada tak macam macam before you start ada maintenance ke apa kalau boleh test sistem ni, deployment and so on. Tapi yang the first two section tu very important. The line tu just something that to show that you are aware lah. I mean, bukan buat projek ni bukan setakat just buat ya. Okay, but just the after you dah complete buat the system tu, macam mana nak deploy, macam mana nak maintain so on. Ada lagi soalan? Okay, that's that question.
No sir.
Tak ada, terima kasih banyaklah. Assalamualaikum.
Salam. Thank you sir.
Thank you sir.
Boleh leave lah ni lah.
Okay.